Hey guys, what's up? It's Crazy Insane Cuber. So today's video is going to be slightly different. I mean, not slightly different, quite different. Let's keep it that way. So most of you would be knowing the total number of ways a Rubik's Cube can be scrambled up, roughly. But for those of you who don't, it's this number. This number is extremely huge, as most of you can see, and most people, they don't know how we arrive at this number. Like, you look at a desk, you look at a cube on a desk, and you think, no one thinks like, okay, 43 quintillion, whatever number that is. So yeah, today we're going to be seeing how this number actually, where we get this number from. So let us look at a Rubik's Cube. It has corners, edges, and centers. Now, centers cannot move, so we can get them out of the way since they don't affect anything. Edges have 2 stickers, and they are 12 in number because edges have 2 stickers, and well, if you count, you will see that they are 12 in number. Corners are 8 in number, and they have 3 stickers, so pretty self-explanatory. Now, let us think only about edges. Let's forget everything else, just edges. If we were to remove all the edges, now we will be having 12 slots empty because there are 12 edges. So if we want to put the first edge in, we have 12 possible slots. And for the next edge, we have 11 possible slots. And for the next, we have 10 possible slots. And it goes on. So the number of ways in which we can assemble all the edges is 12 times 11 times 10 times 9 all the way up to 1. So there's a mathematical notation for this. We write 12 with an exclamation mark next to it. So this is referred to as 12 factorial. Moving on to corners. We have 12 factorial, just keep it in mind. Or you don't need to keep it in mind, actually, never mind. Or just keep it in mind. Moving on to corners, we have 8 possible slots for the first edge. 7 for the second, 6 for the third, and we just keep on going. So the number of ways in which we can assemble all the corners is 8 factorial, which is 8 times 7 times 6 times 3, all the way up to 1, just like the edges. But now we can twist these corners and edges in various ways. We haven't taken that into account yet. The first step is only position, but now we're going towards the various ways of twisting them. So edges can be twisted in 2 ways, since it has 2 stickers. Corners can be twisted in 3 ways, since, well, they have 3 stickers. So if we look at the edges, edge 1, we have 2 ways to twist. Edge 2, we have 2 ways to twist. And we go on. So the total number of ways the edges can all be twisted is 2 times 2 times 2, all the way 12 times, because we have 12 edges. So that can simply be referred to as 2 power 12, or it can be written like this. So in corners, the first corner can be twisted in 3 ways. The second corner can be twisted in 3 ways. The third can be twisted in 3 ways, and so on. So the total number of ways in which corners can be twisted is 3 times 3 times 3, all the way 8 times, since there are 8 corners. So we get 3 power 8. Now to get our number, we multiply all the values. We get 12 factorial times 8 factorial times 2 power 12 times 3 power 8. But as we know, not all combinations with the Rubik's Cube are possible. There are certain impossible combinations. For example, if you just twist one corner, that's not possible. So let us see what the problems we run into are. Let us start with the corners. We can insert 7 corners in any way. There's no problem at all. But the 8th corner is what decides everything, whether it's possible or impossible. And there's only one way you can put the 8th corner such that all the 8 together are in a possible way. If you put the other 2, it's impossible. So that way, the last corner doesn't have an option. So we originally had 3 power 8, but now since the last 3 became a 1, we need to divide 3 power 8 by 3. So 3 power 8 by 3 is 3 power 7. Now this is our new number, which we need to remind ourselves about. Now in the same way, when we look at edges, 11 edges can be inserted in whatever way you want, like however you twist it or permutate it. But the last edge, it depends on the first 11 edges. So the last edge only has one option. It doesn't have an option. Like, it can go to option B, only option A is valid. So well, since the last edge had 2 options and now it became 1, we need to divide 2 power 12 by 2. And that becomes 2 power 11. And there's just one final loophole and we're done. We can never have just 2 pieces swapped in a Rubik's Cube, as that leads to an impossible position. For example, just take 2 corners, pull them out, and put corner A in corner B's position, and put corner B in corner A's position, for example. And you cannot solve that Rubik's Cube. It's impossible. So, removing this loophole, the number of permutations, it gets reduced by half. So what we end up with is 2 power 11 times 3 power 7 times 12 factorial times 8 factorial. Now, when we divide this by 2, the 2 power 11 and 2 can just cancel out as 2 power 10. So we get our final answer as 2 power 10 times 3 power 7 times 12 factorial times 8 factorial. Now, this evaluates to, obviously, a human cannot compute this. A human can't compute this. So you can use a calculator or whatever, and the answer we get is 43 quintillion, 252 quadrillion, 3 trillion, 274 billion, 489 million, 856,000. And this, guess what, is the number of permutations that a Rubik's Cube can assume or can attain. So yeah, I really hoped you liked this different kind of video. It was really fun making this, and yeah, it's quite an interesting process, to be honest. And yeah, I hope you guys enjoyed this. Thank you for watching, and I'll see you in the next video.